I would like to welcome everyone to this webinar where we're going to be discussing the vital importance of field boundaries. My name is Nick Morrow and I'm from Verge Ag. This webinar is part of the On-Farm Operations Optimization Project funded by GRDC as part of the Grain Automate initiative. We're partnered with ACTFA, who has brought together a great team of professionals representing the 4 GRDC regions. So on the webinar with me today is Christian Kapp and Tim Neal, representing the GRDC Northern region. And along with Christian and Tim, we're joined by Jake McHugh from John Deere. Jake is going to be talking about the importance of boundaries and how to create and manage effectively. Jake, let's talk a little bit about boundaries in the John Deere ecosystem.
So my name is Jake McHugh. I am a digital technology lead at John Deere. So effectively, I'm in charge of our digital precision ag offerings across Eastern Australia and New Zealand. So I work really closely with approximately 6 of our dealer groups throughout Eastern Australia and New Zealand and their customers to make sure they can have the most success utilising our precision ag and digital technology offerings. All right, so today I'm going to be talking about boundaries. So the importance of boundaries, why we need them, boundary best practice when it comes to creating and managing those boundaries, how to create those boundaries, and how can we get those boundaries to and from the display quickly and easily. So everything that I am going to be covering here today will be on our operating system for the farm, or what I like to call our precision ag foundation. So it really relies on these key technologies for best utilisation, and that effectively is made up of these 4 key pillars at the bottom here. So we've got our modem, provides connectivity to the machine and to the display. So that allows us to send our data to and from the display. You've got your receiver here, which connects to the display, providing it with an accurate position. And we've got our operation center, which is our offboard cloud-based farm management system, which is obviously collecting data from the display, from the machine, and allowing us to utilize that. So everything I will be speaking about relates to these 4 key technologies. However, they can still utilize this technology if you don't necessarily have all 4 of these. So for instance, if you don't have a connected machine and you didn't have a modem, we can still do this process manually with a USB by obviously plugging USB into display and exporting boundaries that way, re-importing boundaries onto the display utilizing USB and the likes of that. So yeah, that can be done without all of this technology, but for best practice and best performance, these 4 key pillars here will give you the best experience. That is our precision ag workflow at the top there. So when we're talking about our precision ag ecosystem or our operating system for the farm, these are the general steps that we follow: set up and plan work, execute, monitor it, and then analyze performance at the end. Today, I'm primarily talking about the setup and planning work piece as well as the execution piece, because that's primarily where the boundary aspect sits in this. All right, boundaries critical so that our machine knows where it is working, right? What's the boundaries of that field? Obviously, we know that as farm managers, as farm owners, we understand that. However, machines don't, so we need to tell it that and tell it that accurately. And that's where boundaries come in. So boundaries are critical because they allow us to do a range of different things at different levels depending on the accuracy of our boundary. So for a start, job management, they allow us to create specific work tasks for each individual field and assign those to each individual field. They allow us to monitor the job while it's being executed in that field. So obviously, if we know how large that particular field is, then we can get information back to us, such as how much of that field has been completed for that particular task, how long is it going to take to finish that particular task, given how much area there is left. Data management, so data flowing back into our operation center from our display, and I'm talking coverage data here, documentation data, so that might be application, spraying data, yield data, the likes of that. It allows us to manage that data more effectively and keep it clean and accurate. We get weather data in our operation center, and again, we need a boundary to be able to get that weather data, because obviously that gives us a geo-reference of exactly where that field is. It also, at a higher level, allows us to utilize onboard technology, and that's obviously more where we're focusing here today. And I'm talking about turn automation, I'm talking about section control, onboard machine. It allows us to also utilize path planning technology as well. So when it comes to creating and recording boundaries, we like to use a good, better, best model. Good being drawn boundaries. So these are the lowest accuracy because they're not geo-referenced. This map isn't geo-referenced, and you can see obviously this one isn't the best drawing that you'll see out there, but effectively anytime you're dropping one of those data points in the corner of a field, no matter how far you zoom in and how accurate you try to be in terms of placing those data points, you're still only going to be meter accuracy, because those Google Maps that we use there, those background maps, they're not geo-referenced. You think you're dropping a data point on a fence post, but you might not be when it comes to actually utilizing that boundary in the field. So great for that job management, job monitoring piece, managing your data and getting other data such as weather data into your operation center for overall management. Not good for onboard execution and onboard technology utilization, because it simply doesn't have the accuracy to be able to support those onboard technologies. Better is from previous coverage. So if you have a really good coverage map, we can utilize that to draw a boundary around that coverage. So in our operation center, we can take a previous coverage map, could be a spray map, could be a yield map, and simply go in and go create a boundary from previous coverage, and then it'll draw a boundary around everywhere that it's been. Now, one caveat here is that it will draw a boundary around every single piece of coverage that you have. So that's why I've used this map here. Obviously, we can see that we've cut out some contour banks here. It's interpreted that it is outside this field, so it's drawn a boundary around it. So that's just one thing to keep in mind, that if you miss a section of that field, it will interpret that as being outside that field, whether it's actually internally or external to that field, it'll draw a boundary around it. So we can go in and we can delete those shapes, and we can edit this boundary and just utilize that outside shape. But that's just one thing to keep in mind, that it will make assumptions here. So if you are utilizing this tool and creating boundaries from previous coverage, ideally, obviously, you want to create you want to utilize a very accurate coverage map. So that's a coverage map where you know the machine's utilized RTK or SF RTK ideally. If you use another correction signal such as SF3, still obviously much more accurate than drawing it on the map or using SF1. However, you won't have that long-term repeatability that you will have with RTK, so keep that in the back of your mind. We say ideally ground engaging, use a ground engaging implement. So the best scenario is using seeding data, in my opinion. That is what I find to be the most accurate when creating a boundary from previous coverage. Obviously, if I'm using a spray boom, for instance, some people like to run the end of their spray boom out over the fence, so they're covering the fence. They might run them over over a stump in the field or any other obstacles like that. It's pretty easy to do. You don't really think about it while you're executing the job, but when we're creating a boundary, we usually want to exclude those. If I'm using a seeding bar, for instance, obviously I'm not going to be running that seeding bar out over a fence. I'm not going to be running it over stumps. I'm going to be going only where I can physically grow crop, right? And that is critical. All right, so providing we've used that more accurate signal, we've done a good job recording that data. These boundaries are going to be more accurate, and we're going to be able to use these more for onboard technology than we would a drawn boundary, right? So there is potential here. If we've got a really good boundary from previous coverage, that we can use them for the likes of your turn automation, your section control, and the likes of that. But the absolute best case scenario is driven boundaries. So this is what we recommend if anyone wants highly accurate boundaries that they can then utilize for all of their onboard tasks and be confident in it. Take your time, go out and record accurate driven boundaries. That's the best way of doing it. So these are the most accurate, and again, ideally we want to use SF, RTK, use an RTK type correction signal for that long-term repeatability, and you will have a much more accurate boundary here to utilize. So when we go out and we're recording a driven boundary, basically we can have confidence in terms of where that boundary has been recorded, and therefore you're going to be able to use this for those onboard technologies such as your turn automation, such as our boundary track, such as our section control and our path planning and guidance, because we have full confidence in that boundary and where it's been recorded. In terms of best practice for recording those boundaries, like I said, and I've said throughout this whole presentation, you want to use a high correction signal, RTK, SF RTK. We want to use a ground engaging implement. So even if we're driving a boundary and you're going out in your machine to drive that boundary while you're doing an operation, ideally you want that to be a ground engaging implement. For the same reasons I outlined earlier, we want to make sure maybe it's a seeding bar. If we use a seeding bar, obviously we're not going over any obstacles and including those in our boundaries, because we only want to create a boundary on cropping area, right? So we don't want to include the entire field in that boundary in terms of right along that fence line. We want to only cover the cropping area, because that's the area the machine will actually physically be working in, and that's where we want the edge of that boundary to be, is where that machine will actually physically be working, right? So we want there to be a buffer, and that's best practice when we go out and we're recording a boundary. If you've got a ground engaging implement like a seeding bar on there, you go out and you make sure that there's say a 2 meter buffer between your fence line and where we're actually planting the crop, and record your boundary on that cropping area. Absolute best case scenario, use a machine without an implement for best accuracy. Right, so essentially the people that take this most seriously and want the most accurate boundaries possible for their farming system, what they'll usually do is they'll put a receiver on their ute, or maybe on a gator or a UTV, and then they'll go out and they'll just physically drive that cropping area. The reason they'll do that is because obviously if I have an implement on there, say I'm out seeding and I'm doing my seeding headlands, my core focus isn't necessarily recording a boundary, although I'm recording a boundary while I'm doing it. I'm still out there to do a seeding job, for instance. I can get distracted, and that can hamper the accuracy of your boundaries. The best way of doing it is without an implement on a vehicle such as a ute. Make sure your offsets are correct, and then just go and physically drive that cropping area. That is the best way of getting an accurate boundary. All right, so in terms of creating a driven boundary, it's pretty straightforward. We go into menu and then we go into applications, right? And then we navigate to our fields and boundaries. then you're effectively going to select the client farm field that you want. Once you've got the client farm field that you want, you hit create boundary. You can see here you get an option to create from a previous coverage map, but we select create driven boundary. Here we can select a name and we can select other settings for that boundary, right? So I'm just naming it on-farm operations optimization for this particular webinar here today. So that hence the OFOO. You can select where that boundary is being recorded from. So whether that is machine's GPS or where that implement is. So obviously if you have an implement on there, you're going to do that implement where it points. So it'll record it on the edge of that implement, and then you select left or right, right? So if we're doing machine GPS, by default, it'll be down the middle of the machine, wherever the GPS is. I've selected left and put an offset on it here. You might do that if you're in a gator as well. So that if the GPS is on the middle of the gator or UTV, you might put it, say, half a meter or so out so that it lines up with the edge of the wheels on your gator. It's completely up to you as to how you manage that. And then once you've entered all of that information, we just hit OK and we begin recording. All right, so then we can start recording and we'll start driving. As we're driving, this boundary will be recording in the background here, so you don't need to keep that panel open to keep recording a boundary. Everyone thinks that now that they're recording boundary, they have to keep that panel open. If you exit out of that, that'll continue recording that boundary, as we can see on the main map page here, right? And you'll see in our location information where it normally shows the field that we're in, it now has a recording sign there, so it shows that we're still recording that boundary, right? So as we can see on our map page here, we're driving along and we're recording a boundary behind us. In the past, typically this would show up as a pink color. However, now there has been an update this year to our boundaries that shows whether the boundary is autonomy capable or non-autonomy capable. So effectively, this is a technology that is allowing our customers to build their capabilities for the future, so that if they do wish to use autonomous machines in the future, they can start recording autonomous boundaries now. Today, I'm not focusing on autonomous boundaries. I'm just focusing on recording a good boundary in general. So you'll notice that it's orange. It's not autonomous capable. However, if you do want autonomy capable boundary, there's just a couple of different metrics there that you have to meet as a minimum requirement. That being, you have to have a 7000 or a 7500 series receiver. You have to be on radio RTK or SF RTK. You have to be on a minimum of 80% accuracy at all times. Otherwise, that will fall back to the non-autonomy capable boundary like I'm recording here today. So when recording a boundary, there's also the capability that when I open this recording panel up again, I can come back in and I can pause that boundary. Now you'll notice here that it's doing a dotted line from the last data point that it dropped. Now when I hit resume, that's just going to snap a straight line from where that last data point was. So you can potentially use this when recording fence lines if you want that to be dead straight, and you know that it's a dead straight fence line. You can pause it at one end, hit resume at the next, and it's just going to snap a straight line up that fence line, so that you know when you're using boundary track or other guidance technology from that boundary, you know that you're going to have straight fence lines, right? So that's one easy way to do it. Note that if we're recording an autonomous boundary, I can't pause it. If I pause it for too long, essentially it's going to fall back to the non-autonomous capable. So you don't want to pause it while you're doing an autonomous capable boundary. Once I get back towards where I started that boundary, all I have to do is hit save, and it's going to snap a straight line from where my last data point was to where I currently am, along that dotted line back to the starting point, right? So obviously you want to do it as close as possible to that starting point, but I'd recommend you do it slightly short, a few meters short. Obviously you don't want You don't want to go past that starting point, because then you'll end up with a little jagged edge, which isn't ideal. Not the end of the world, but I wouldn't recommend it. So ideally, stop a few meters short of where you started, and then just hit your save button there, and then you will have your boundary finished for that particular field. All right, so now that we've got that boundary recorded there, it's very simple to export this to a USB or to your operation center. We just navigate back to menu, and we go to system this time instead of applications, and then to our file manager. Once you're in file manager, we just want to select export, and then go to custom export. Now, this will give you an option. Obviously, I don't have it here today on a simulator here that is not connected to my operation center. If you're in a machine that was connected, you would have the option here to select between a USB or to export to your operation center. Right, all this simulation here today, I've just simulated exporting to USB, but it's the exact same process no matter which one of the two you choose, whether you're exporting to operation center or to USB. It's the same process. Hit next. You can select to export all data, but we're going to do a selection here, and we can do it at the client level, you can do it at the farm level, or you can do it at the field level. So I've selected a client here, I've selected a farm, but I've left field blank, so effectively it's going to do everything that I've recorded in that farm. If I selected a specific field, it's going to export everything in that particular field. Just gives us the customizability to export only the data that we want to export. Now I'm just doing setup data here today. As we can see, I'm going to hit the pencil, and I'm just going to make sure within that setup data I'm just doing boundaries, because that's all I want to export back to my operation center here. Hit OK, hit next, leave it on current systems for exporting to OpCenter, and then it's going to export that data. That data has now been exported to my USB. If I had selected OpCenter, that data would now be back in my OpCenter. It's the exact same process. So now that's done. Very easy to do, but we do have another tool that makes it even easier again, which is called Data Sync Setup. So effectively, Data Sync Setup syncs all of our Gen 4 and G5 displays with our operation center so that you're all working off the same database here. So effectively, if I add anything in my displays or I add anything in my operation center, it's going to sync it across those other databases to make sure that they're all on the exact same database with the exact same information in it, right? So it makes it easy. You don't have to think about it. So effectively what that means is if I go into my operation center and I add all of my client farm field structure, so I've got all my naming structure there, it's going to sync it straight to all of my machines, straight to all of my displays that I've synced, right? Then I go on that machine because I want to record a boundary. I jump in there and I have all of my client farm fields there ready to go that I've entered in my OpCenter. I don't have to send them to that machine. They've already been sent there automatically for me. I select the field that I want to record a boundary in, like I've just done. Go and record that boundary. Once you've finished recording it, you should happen to do that export stage. As soon as you've finished recording it, that boundary will be straight back in your operation center again, ready to go. And it'll be in any other machines that you've synced as well. So it's just making your life easy. The best bit about data sync is that you don't really have to use data sync. It's just doing everything in the background for you to make sure that you've got that data where you need it, when you need it. So the good thing about that is any boundaries you have in your OpCenter, any path planning that you choose to do in OpCenter or other platforms, effectively any guidance lines, they're going to sync straight back to all of your other machines so that you can then go and execute on that data straight away. So that's why it is a very easy tool. If I did have those boundaries back in my OpCenter, and I did want to create work for my machines to go and execute on, including those guidance plans that I've then created using those boundaries, I could also use Work Planner. That's another tool. So saves time in the cab. You're not having to set up which guidance lines you're using in the particular in the cab. So you're not selecting your client farm fields. You're not selecting your guidance plans. any of your crops or varieties or rates or any of that information. You set that up offboard on your Operations Center web or your Operations Center mobile, and you send that to your display, be it a Gen 4 or a G5 display, to then execute on. Right, so it makes it easy for the operator, whether that's yourself or anyone that works for you, to then just simply enter that field and that plan pops up for them, and they've got all of that path planning and they're ready to go. All right, so that wraps up the presentation piece. I'll just quickly now jump into my Operations Center here, and I'll show you what it looks like once I have that that boundary file that I exported from my display earlier, and now I want to get that into my Operations Center if I was using USB. Now we come up to our More here, and then we drop that down, and you'll find that we have a Files tool here. So from the main map page, I'm going to navigate to our Files, and then I'm just simply going to grab that file and upload it here. So I'm going to upload a setup file. You can select setup file or boundaries. Does not matter which one you select. I'm just going to use setup file here. Let that load, and then I'm going to grab this boundary file here and put it in OpCenter. One key thing to note here is that you must have that file zipped, otherwise OpCenter will not take it. So the display exports it as an unzipped folder. When we get that folder, we just quickly have to send to a compressed folder. So zip folder, hit that, make sure it's zipped. Once it's zipped, you can put that straight into your Operations Center. Hit upload, and then we're going to have that boundary there ready to go. So that's just one key thing to remember. If I had a connected machine, so I had that modem in my machine, I wouldn't have to worry about any of that step. I wouldn't have to use USB. I wouldn't have to worry about zipping files or anything like that. It's just going to do it for me automatically. It'd be the same export process that I showed you earlier, but you'd select Operations Center instead, hit send, and it would send it straight to OpCenter, and it'd be in here ready to go. So I'd effectively skip the step that I've just shown you. If you had data sync on, another step again, you wouldn't have to export it. You wouldn't have to import it into OpCenter. You wouldn't have to do anything. It's just automatically going to be here ready to go. Now that I'm in my Operations Center and I've uploaded that file, I can see under setup files, the processing is complete for that file that I exported. I'm going to jump up to my setup tool here, drop that down, and navigate to land. Lands where I'm going to manage all of my client farm field lists, all of my boundaries, guidance signs, and flags. So all of that physical information that I need to then execute on a job on a machine. This is where I manage it from. So I can come into my Operations Center here, and this is the actual boundary that I had just shown you on that video that I recorded. OFOO on farm operations optimization, field 1, that's what I recorded on that display. I've brought it back in, and I can see obviously it's not the cleanest boundary you will have seen, but that's what happens when you record it using a simulation. But you'll see that boundary that I recorded and exported from my display is now my Operations Center. So very easy to do, very fast. Once you've got it here, it's then free to be able to utilize to create guidance lines, create path plans, send to other third-party software. And then once we've got that other information that we then want to use to execute on a job, I can then either use my data sync it straight back to my Gen 4 G5 display. I can put it back on a USB using my setup file creator tool here under setup, or I can use my work planner tool to create a job for that particular field and then dispatch that to a Gen 4 or G5 display to execute on with all of my guidance lines and other information in that as well. So that effectively sums up everything that I wanted to cover here today in terms of boundary creation, boundary recording, and also boundary management. I'll pass back off to you now, Christian.
Thanks, Jack. That's good. Yeah, that's kind of closed the loop. Thanks very much. I do have one question for you. When you say you can't, if you want an automate capable boundary, you can't pause it. So what do you do on a straight fence line that you want to keep straight? You just got to drive it.
Got two options. Either you can just drive it, or potentially if you did have guidance lines there for that existing fence line, it's obviously another complete another dimension to it. But if you did have auto track lines for that particular field and that particular fence line, you could potentially auto track it as well. That's the only way you could get a straight line, but unfortunately, no, you can't pause it for the simple reason of there's a large amount of metadata that it's collecting in the background to make sure that that boundary is true and accurate to that field, so that we know that when we're putting it on an autonomous machine and we're going to obviously let that machine complete that job without an operator, that it has an accurate boundary. It's going to do the job accurately and safely. Safely being the key piece there.
And it needs to be a 7,000 receiver.
7,000 or 7,500 series receiver. Yeah, they're the only receivers that have the capability to record that metadata in the background.
Having said all that, though, we don't have those capable machines yet in Australia, do we?
No, exactly. We don't have autonomous machines yet. They are coming. So effectively, we want to give our customers the tools here now, so that they can start to build their skills, build their data sets, so that when in the future we do have autonomy, they've already got the skill set there in terms of utilising our digital tools, in terms of utilising our onboard technology. They've got the skills there to utilise that autonomous technology. Otherwise, when we do get autonomous technology, they're going to be starting from square one. You're going to have to be learning how to record autonomous boundaries. You're going to have to be learning how to use onboard technology such as path planning or boundary track or turn automation. Whereas if we can start learning those key tools now and build our skills, then when it comes time to adopt autonomy, it's going to be a lot easier. So as we build our autonomous capability, we want our growers, we want our customers to build their autonomous capabilities as well.
And just chime in there with GRDC, the Grain Automate program is exactly that as well. It's to help farmers prep up in future readiness for autonomy. So, it's a good point you make. So I think that's a key outcome of the Grain Automate project, is helping people get ready.
Yeah, absolutely. If you start now, then we'll be ready to go once those autonomous capabilities are released. Otherwise, like I said, we'll be starting at square one, and then you have to learn all the tools that we have available already when we actually have autonomy ready to go. Otherwise, if we start now, we build on those technologies. When we do get it, they'll be able to jump right in and utilise that technology to its full capability. Because effectively, our autonomous machines that we are using, they're already using all of the technology that we have available today in terms of our turn automation, path planning tools, our machine sync, our implement guidance, all of these tools that we have available today, our autonomous machines are using. They're not some far-fetched futuristic technology that we've never seen before. The majority of the technology it's using, and we've already got today, it's just expanding on it. It's all building blocks, foundational building blocks to that autonomous capability.
So I'm going to chat a little bit about Launchpad, which we focus directly on path planning specifically. and we look at ourselves as doing the same thing that Jake was just talking about, getting people ready to for the autonomous future, going beyond that AB line that's stuck in the machine, in the shed. So I'm going to take you through a couple of pieces of Launchpad and specifically how it integrates with John Deere. So we do have an integration with John Deere. You can create a Launchpad account that connects to Operations Center with all of the same features and functionality that you might expect with another John Deere partner. So you can sign up and then go through connections and pick which organizations you want to link to John Deere. I happen to be already signed in and everything. We're not going to go through a sign-in process, but what you'll see is once I sign in, I can use my John Deere username and password. So if I create a John Deere account with Launchpad, I can just keep one username password to work with Launchpad. One of the things that I wanted to mention is that we primarily are working with boundaries today. So when any data sharing is all grower farm field and boundary information, nothing else at this point. But everything that Jake talked about with accurate boundaries, I mean, we rely on. So like a lot of our process starts with good, accurate boundaries. And half of the time we're working with customers, we're working with them to understand that, an accurate boundary is what's going to help them create a better path plan, create a more efficient path plan, etc. So right here, this is an organization, Cordy Farms. This is in Queensland. It's connected to John Deere. If we're working back and forth with OpCenter, you can always update information in OpCenter and we can get updated data. We do use OpCenter as the master data. So if you're working with OpCenter and also with Launchpad, we expect Operations Center to be where your master data is for high accuracy field boundaries, etc. So you can always update this by resyncing. I did this not very long ago, so I'm all up to date here. So this is my entire organization now within Launchpad, and this is a John Deere field boundary. So let's talk a little bit about path planning. So I'm going to create a new path plan here with this boundary, and basically we need two main pieces of information prior to creating a path plan. We need the equipment width, and so I'm going to use a 18-meter seeder, a larger seeder. And we have to define the number of headland passes. So I'm going to create a path plan right now. And what I'm doing is we're creating basically not just a path plan, but we're creating a set of scenarios for the user to investigate and make decisions on. We focus on edges. So we calculate all of the edges of the field. And then we add a couple of other additional headings that might relate to soil loss, least coverage, least amount of overlap, etc. So what we have here is we have our edges that we can select here. So this is every edge. For each field part, we calculate and align to 5 different edges. So this is each individual field part. We also do some calculated edges. So we will actually run through a host of potential headings and figure out the best one. So we can look at the least number of tracks or the shortest distance traveled, etc. And some of these things really depend on what the grower is trying to achieve. Sometimes they want simple. They want to just go along that longest fence line. Sometimes they really want to reduce the number of turns or some balance in between that. Additionally, from that, we can start to look at a little bit of field statistics here. So for my entire field, I have 128 turns, tracks or turns, 100 kilometers of distance, and then my turn and perimeter passes in total. But I can also see that information for each field part because this is separated by a pretty big area, so they might actually farm those. Sorry, this should be paddocks. Let's farm those paddocks effectively differently. So I can actually look at that field summary per part. So this part has 45 and this part has 83. So those are some of our just summary statistics that that everybody's really going to base their decisions on. I want to get this done in the least amount of time. I want to have the least amount of soil erosion. I have the least amount of overlap. They're minimizing things constantly or looking at the balance of those. Finally, we have a coverage breakdown, and I'll pull on a coverage layer here. One of the things you'll probably have in the past have noticed that coverage maps and overlap are really something always viewed after the fact. And one of the things that we looked at was, hey, we can plan that. So we can pre-plan where that overlap's going to occur. We can pre-plan the amount of overlap that's going to happen based on that implement width to help users make decisions on where they want to align, etc. So from the selected edge, we're going to always force every track over, about like boundary track from John Deere. And there's going to be zero overlap on this edge. And we're going to push all of that overlap over this edge, because even though users might think that their fields are rectangular and then they have, parallel edges, they don't. So we help them understand where that overlap's going to go, etc. Finally, if you have existing run lines, we can help. You can create a path plan using that existing run line. And this is a new feature for us, so I'm gonna admit that it's slightly embarrassed. I have to hand edit some AB line information in here. We will definitely improve that. We're actually looking at pulling in AB line information from John Deere Operations Center. But we can add an existing AB line, and then we can create a path plan based on that run line. So if you're in a controlled traffic scenario and it doesn't matter, you're going to be running down that run line, but you want to create another path plan for a different operation, you can actually use this track in here. And notice that you're going to create some extra overlap in this case, but it may be a scenario where that's the run line that I'm going to use. And it could potentially be outside of this paddock, or it could be inside, but we can force our path plans to adhere to that run line. So I'm going to save this plan. So I had a bunch of scenarios there. I've evaluated what I want to do. In this case, I want to align it to that AB line. I'm going to save that plan. So one of the things that I have is when I create equipment, I can actually create the width, my working speed, but I can also start to look at where the tires are. So track width of that tire and those tire width. So I've defined that for each one of these operations. For my seeding, harvest, and application, I think I have much wider tire here at 800 millimeters for harvest. I can start to look at wheel traffic now. So here are all of my saved plans. So we call these farmer decisions. This means that someone has made a decision that they want their vehicle and their equipment to operate within the field in a particular way because of something that they wanted to achieve. Most of the time that's efficiency, but there are other parameters that producers and growers want to achieve. In one case, it's I want to be able to align my wheel tracks to reduce compaction and all of the benefits that controlled traffic provides. So because I defined that, I can see here for this plan, I have about 7.5 hectares of wheel traffic. So this is two-dimensional, so this is covering the whole piece. I can also show those wheel tracks. So if I zoom way in here, this is going to be my actual wheel track area here, and then summarize over that entire paddock. So we can use that information to then align. So I want to potentially align various operations within the same wheel track. And then I can also summarize across an entire season what my wheel traffic area is. Because in this case, this is just seeding at 18 meters, and I have 7.5 hectares. But what happens when my applicator rig gets out there? What happens when my harvester gets out there, et cetera? And, there's calculators out there, from CTF calculator, from ACTFA, et cetera, that worked to show kind of one-dimensional. One of the things, we took that just another step further to calculate that in your actual paddock. So this is what your paddock looks like for that. So with that wheel traffic information, we can actually start to summarize over the entire, we can align path plans and we can summarize over an entire season. So in this case, I have a concept of a seasonal plan, and this is for a paddock. This is all of the plans for my operations that I have. I simplified this a little bit where I'm just looking at seeding, harvest, and application, but you can do all of those operations. So in this case, I took that same paddock, and I have a 36-meter sprayer, a 12-meter seeder, and a 12-meter front for harvest. And I created those plans together. I made sure that they were aligned. And here's my seasonal plan. So here are all three plans here. And then we calculate the total wheel traffic area for the entire field. So basically the wheeled area for this paddock is 29.5 hectare. What's interesting is we're hearing a lot of feedback from the growers within the project about moving up in seeder size and what effect that will have on their efficiency. Obviously, their efficiency will go up, but what effect will that have on wheel traffic area? So in this allows us to easily compare what that might be. So on this second scenario I created, we have a still a 12-meter front and a 36-meter application, but we added in an 18-meter seeder. And now you see our total wheeled area is about 35 hectares. So we moved from 29.5 to about 35 hectares of wheeled area by moving up to an 18-meter seeder. So we increased our wheel traffic area, but we also increased our efficiency a bit as well. So kind of giving the grower or the producer the tools to help make that decision. How far off do they want to get on their wheeled area? How much are they willing to let the wheel traffic area grow to gain that efficiency by going up to a larger toolbar? This was as part of our project. This was what was worked on over the last just couple of months. Is focusing on wheel traffic area alignment, summarizing that over the paddock, and then of course summarizing that to the farm to help give growers kind of the impact of what going to 12 to 18 meters would give them. So I want to take a slightly different look. We also do a little bit of work in terrain with vertical. So I'm going to grab a field, sorry, a paddock, apologize, such as this one in the Queensland area. And we grab some digital terrain information. So I'm going to run another seeding plan here, but I'm going to use curve tracks. And then I want to calculate slopes for that. And I'm going to create that path plan. And we're going to take that terrain model and we're going to build some contours for that. So I'll turn that off. And you'll see here that I have these contours that I created that, kind of mimic what's underneath there. Because those are the real contours that they have. But what I'm going to do just to explain a little bit about what we do automatically is I'm going to use the kind of a real easy single contour example. If I turn on the slope here, so what this is showing is everything that's red is greater than 8% slope. So this means my tracks are either going up or I'm going down at greater than 8%. So this is kind of a tough area on either side of that ridge. And that's why they're farming that in contour. So I took this as an example that was really dramatic. I could take that same thing and let me turn off contours here. And I'm going to select this contour right here. And I'm going to create another path plan. So now I have a curved plan here. So I've created these curved tracks based off of this smoothed contour, and then that's replicated across the entire paddock. Now notice what my slope looks like, much more in the greens. So this is what this is what they really want to achieve. And I could eventually, if I wanted to spend more work at that, I could actually build every single one of those contours, and I could create different field parts with different patterns that become more and more and more parallel to the terrain. So this is where we're also focused. Not so much of that in Australia, but there's a decent amount. And growers are looking for tools that they can use to evaluate whether that's worth it. Because obviously a curved path is more complicated. It's tougher on equipment, but if it means less soil erosion, etc., people are going to use that where it works out for them. So now to talk just a little bit about exporting back to John Deere Operations Center. I'm going to take that same contour, one that I just created, and I'm going to select that plan. You can select multiple plans. You could select your entire farm if you wanted to and export. And we export to a variety of monitor formats, including John Deere. So we can export as a file to put on a USB, to take out to your vehicle, but we really promote going to Operations Center. So even if you don't have connectivity to your machine, we'd still prefer that it go to Operations Center, it be part of all of the guidance information in land, and then you can use Setup Creator or Work Planner to send that information either to a USB stick or directly to your machine. It allows you to use John Deere tools, and they know what's changing. They then support their machines and their monitors, and I think it's a much better experience. But it allows for a very seamless experience. In this case, I'm going to send the headland tracks. I'm going to send all of the individual inner tracks, the boundary, as well as the inner boundary, which is the section control boundary. And I'm going to export that. I'm going to pop over to my OpCenter account. And there is my new setup file. So we actually send that Operations Center as a setup file. And then we let Operations Center process that setup file. And then that guidance information then ends up in land. So here's my paddock in land. And notice these are adaptive curves. So this is my headland track as an adaptive curve that's drivable based on the accuracy of that boundary. This particular boundary was not even close to accurate. I hand drew it. But you can steer that up into the corners. And then if we look at this other adaptive curve here, this is every single independent track. So when we talk about getting kind of ready for the future, being able to define exactly what track you want, because today typically it's striking the AB line in the monitor, depending on what technology you use to do that, and the monitor then replicates that across the field. There is the ability to define every single one of these independently, and as they get into more and more complicated situations, whether that's splitting up the paddock for different patterns or getting outside of straight and getting into the curved territory, we're going to have to start to work with these every track as an independent thing. So this is a case where I could use Setup Creator and I could grab all of these adaptive curves and I could build that setup file and send to my equipment. I believe Work Planner only works with AB lines yet, but I'm sure John Deere will bring that along shortly. So that's kind of our end-to-end with Launchpad. I can bring paddock boundaries in from Operations Center. I can create a path plan from those based on whether it's depending on whether I'm looking at efficiency or I'm looking at overlap or I'm looking at terrain. And then I can export those back to Operations Center and then off to my machine. One last piece that I wanted to bring up, something that we're working on is routing. So not just the guidance of that piece of equipment, but which way do you turn? John Deere turn automation allows you to automate that turn, but you still have to make a decision on which way to go. One of the things that I wanted to bring up that we've noticed is the lack of mapped internal boundaries. So this is that same paddock that I was showing before, but now I've mapped the trees within that boundaries, and notice the difference. Just by mapping those internal boundaries, what the complexity difference, based on pre-planning that made. And no more than looking at what the route would be is showing how complicated that gets. So I'm going to show this route now. If I zoom out here a little bit, my green dot is where I'm going to start. My red dot is where I'm going to end. I'm going to go from green to red. That's kind of my general area, my general direction. But showing where I'm turning, and then how I'm getting around that obstacle, how I'm doing the inner headland pass, and I'm navigating that field. So this is kind of the future of where we're going is we're going to start with what we call operator guided routes, because not all we're not ready to do anything in the equipment, and the equipment is not ready. But one of the problems that we're hearing from the field is that I just need help guiding my operators. Like, 8,000 text messages back and forth and WhatsApp messages back and forth on where to go and where to turn and how to do this. We want to help growers be able to provide task instructions to their operators on how they want the paddock farmed. And so the focus is on the mobile experience. So this would be, I'm simulating this, of course, and I can't actually start the navigation because it will take me to my home. I didn't fake the location, but this would be it's supported on a mobile device, and this would be that same route information. So again, this isn't focused today on actual vehicle guidance and automation. This is really focused on the operator. So if you think about the path plan and the guidance information we just sent to Operations Center, that's for the equipment. So that's guidance for the equipment. Now we're supplementing that with guidance for the operator, because the operator could still take that guidance information and be reasonably inefficient within that field. So we're going to work to help guide that operator for the grower. And that's my quick tour, Christian, of Launchpad and how it connects with John Deere Operations Center and how we're working to help growers in Australia be more efficient.